Okay, so here we go. Here's some here are the proofs actually from section 4.3. Excuse me. So we've got to prove we have congruent triangles. And in 4.3, the only way we can do that is if we can prove that all angle pairs and all side pairs are congruent. So, yeah. Oh, yeah. Actually, no, I'm sorry. This proof's a little different. I'm not thinking clearly. So what we have to do in this one is prove that if BD bisects angle B and BD is perpendicular to AC, angle A is congruent to angle C. So this actually has nothing to do with congruent sides. It actually has to do with congruent angles. So the first step for this one is realizing that BD bisects angle B. What that means is we have a pair of congruent angles. And that's always something you'll see. BD bisects angle B, you have a pair of congruent angles. Now the other thing is this. We know BD is perpendicular to AC. You can see one right angle here, but really perpendicular lines create multiple right angles. And what we're going to use for this proof is the fact that, hey, I've got two angles here that are congruent. Hey, I've got two right angles that are congruent. That means by the third angles theorem, angle A has to be congruent to angle C. So this one's kind of tough formality-wise to explain, but we can find two pairs of congruent angles to begin with. We can use the third pair doing the third angles theorem. So here we go to walk through it. Okay, so statements, reasons, one, bleh, given, two, angle ABD is congruent to angle CBD. That's the ones there. And that's from the definition of angle bisector. Okay, we're going to use this a lot this chapter, the definition of angle bisector, so get used to it. But angle ABD and angle CBD are congruent because we have an angle bisector. Now the third step, this is a two-part proof. It's kind of annoying, but we have to actually say angle ADB and angle CDB are right angles. Okay, and that's because perpendicular lines form right angles. Technically they form four, but we can just say they form right angles. And then step 4, angle ADB is congruent to angle CDB because all right angles are congruent. And now we can finally say we have two pairs of congruent angles, so angle A is congruent to angle C by the third angles theorem. Okay. So this is not a triangle congruence proof. We'll do that later. What this proof is we're just proving, okay, that we have a pair of congruent angles in two triangles by showing we have two pairs of congruent angles to begin with. So by the third angles theorem, they have to be congruent. Okay. All right, now next problem. And these proofs are actually quite simple for our what we're going to be using, because we're trying to prove that we have congruent polygons, specifically triangles. Well, the way we do that is we have to prove we have all pairs of corresponding sides congruent and all pairs of angles congruent. They've already given us, to be honest, they gave us two pairs of angles. Q and S are congruent and T and P are congruent. So what I have to figure out is how do I prove the third pair of angles are congruent? There's two ways to do that, but they are congruent. We'll come back to that in a moment. Okay, and then they gave us TR is congruent to PR. They gave us an RP is congruent to RQ. They gave us RT is congruent to RS. Okay, and they gave us that PQ is congruent to TS. Now there's two things we have to do for this one. Again, like 90% of the problem's done. We just have two things to do. We never did state that QR and SR are congruent. We know they are because this is an isosceles triangle, but we're going to have to state that they are congruent. So we'll jump into this. And again, Mr. Moyer's feeling very lazy right now. So given, blat, right there. Okay. Now here's the deal. I'm going to do the angles next. I first of all can't just say angle R is congruent to angle R because there's multiple angle R's here. So I have to say angle PRQ is congruent to angle, not triangle, sorry, angle TRS. And that's because, well, two things. You could use the third angles theorem, because we got two pairs of angles already congruent. Or we could use vertical angles theorem, which is what I suggest you use. And again, I'm running out of space. I'm just being really lazy with this. So I've got now my 3 pairs of angles taken care of. 1, 2, and then 3 for the angles. Sorry, 1 angle, 2 angle, 3 angle. Now here's the deal. I have 1 pair of sides here. I have the second pair of sides here. What I'm going to have to do is use the fact that we know TR is congruent to RS, and that PR is congruent to RQ. So for our third step, we can say SR is congruent to RQ. Yeah, RQ. That's our last pair of sides by transitive property. Okay, and now we've proven that 3 pairs of sides are congruent, 3 pairs of angles are congruent. So now I can say that triangle PRQ is congruent to triangle TRS by definition of congruent triangle. So again, that's a tough one. This is going to get easier as the chapter goes on, but the thing I'm really worried about mostly right now is just the idea of proving things that, like angles and sides are congruent, and then seeing again transitivity a little bit and vertical angles. All right, the next one says write a paragraph proof. I don't honestly care. We'll do 2 column. It's just easier to do 2 column in a lot of these, at least for the way our book structures it. So we've been given that angle WXZ, so here's WXZ, is congruent to angle YXZ. So those 2 angles are congruent. So we got a pair of congruent angles. Next, and then we'd also been given XZW, so XZW is congruent to XZY. Okay, so 2 pairs of angles. Okay. Then we've been given that WX is congruent to YX, that's 1 pair of sides, and that WZ is congruent to YZ, second pair of sides. So in our proof, we actually have all of this, and that's 2 pairs of sides. What I've got to figure out now is my third pair of angles, so the A and G is going to stand for, and then my third pair of sides. So I got to find those. Now the third pair of angles hopefully is pretty easy. We haven't mentioned them yet in the problem. That'd be angles W and angle Y. And hopefully you can catch that angle W and angle Y are going to have to be congruent by the third angles theorem, because we already have 2 pairs of angles, two pairs of angles congruent. Angle pair 1, angle pair 2, automatically third pair is congruent. The pair of sides, and this is something that a lot of people don't catch at first, but we see it now finally, it's something we haven't used but it's going to come back, is that XZ is congruent to XZ because it's the same segment. That's reflexive property. And get ready to see this a lot, where the triangles share common sides. That's where we get our third pair of congruent sides by reflexive property. And now I'm done. I can say triangle WXZ is congruent to triangle YXZ by definition of congruent triangle. All right. And then last but not least, at least last proof we're going to cover it in class. Angle J is congruent to angle P, that's given. JK is congruent to PM, that's given. JL is congruent to PL, that's given. And then here's our last statement. L is bisected by KM. So L bisects KM, point L does. What that means is it has to cut it into congruent segments. So there's our third pair of sides. So here's 1 pair of sides, here's 2 pair of sides. There's our third pair of sides. So if I just start with the problem. Oh, and I'm sorry, I should have said this. Again, we're going to try to prove these 2 triangles are congruent. We'll do that by showing all pairs of sides are congruent and all angle pairs are congruent. So again, 1 given. Next, we can say KL is congruent to LM, definition of bisect. Okay. 3 and 4 are a little bit harder to get to the angles because I've only got one pair of angles right now. Well, hopefully looking at the drawing, the second pair of angles jumps out at you because we've been using this a ton and I've kept pushing it all year long. Angle JLK, grew it to angle PLM by the vertical angles theorem. Got a pair of vertical angles. And now that I've got two pairs of angles, 1 and 2, I can say now that angle K has to be congruent to angle M by the third angles theorem. And that's our third pair of angles. So now we have 3 pairs of sides, 1, 2, and then the third pair of sides. 3 pairs of angles, 1, 2, and 3. So now I can say triangle JLK is congruent to triangle PLM. Definition of congruent triangles. Okay. Now again, I'm sprinting through these. We're going to have taken a little bit more time in class to go through it and talked a bit more. But if you have any questions at all, come in. Okay, come in because this is it. This is the big focus of the chapter. So hopefully that helps.